Hello everybody, welcome to CAMS Engineering. This is part 4 for how to make a powerful subassembly from Autodesk Subassembly Composer. In previous 3 videos we had seen how to make lane layers, different conditions for our shoulder slope by using if function, fill daylight, high fill widening, and so on. I think you don't like it because I have got only 8 subscribers. Today I will continue from last point. Let's start. First we will insert our input parameters for cut condition. The first one is FCS, its flat cut slope. It is not double, it's slope. Its default value is 3:1 as we have seen in previous video for soil type of material, but you can change it as per your condition. The next one is MCS, its medium cut slope. It is not double, it's slope. Its default value is 2:1 as we have seen in previous video for soil type of material, but you can change it as per your condition. The third one is SCS, its steep cut slope. It is not double, it's slope. Its default value is 1.5:1 as we have seen in previous video for soil type of material, but you can change it as per your condition. Next, DLI, it is daylight insertion point. Again, you can give any number including 0. It is double. We will give 0.5 meter away from our ditch. Now come to our flowchart, insert a flowchart and open it. First we will insert daylight insertion point, insert a point. It starts from point. Okay, first we have to give the same point number for all our ditches. Because this condition must be useful for all ditch cases, let's first see the points. For masonry U-shaped ditch it is 0.33, and change it to reinforced concrete U-shaped ditch. For reinforced concrete U-shaped ditch it is 0.26, change it to trapezoidal shaped ditch. For trapezoidal shaped ditch it is 0.41. Now change these 3 point numbers to 1 point number. You can give any number but greater than the last point number. We will give our point number 100. Change 0.41 to 0.100. Come to masonry U-shaped ditch. Change 0.33 to 0.100. Come to reinforced concrete U-shaped ditch. Change 0.26 to 0.100. Now we can proceed. Delete it. Insert a point. It is delta x delta y. It starts from our new point number that is 0.100. Its delta x is positive daylight insertion point. And draw a link. Now we will insert an auxiliary point. It is slope to surface. It starts from point 101. Its slope is positive flat cut slope. Its surface target is EG. This is our first cut condition. Next, we will insert the second auxiliary point. It is slope to surface. It starts from point 101. Its slope is positive medium cut slope. Its surface target is EG. This is our second cut condition. Next, we will insert the third auxiliary point. It is slope to surface. It starts from point 101. Its slope is positive steep cut slope. Its surface target is EG. This is our third cut condition. Now we will define a variable. We will give its name CS. That is cut slope, but you can give any name. It is double. We will give its default flat cut slope, but you can give one from the 3 condition. Now we will decide our condition. Insert decision. Its condition is ap8.y minus 0.101.y less than or equal to 10. If it is true, we will set a variable. Insert set variable value. Its name is our new cut slope for its variable value. It's preferable to copy it from fill condition and edit the parameters. Copy and paste using Ctrl+C and Ctrl+V. Change AP3 to AP6. Change point 11 to point 101, and since it is cut, change negative to positive or positive to negative, and change fill to cut. Again, change AP4 to AP7, change point 11 to point 101, and since it is cut, change negative to positive or positive to negative, and change fill to cut. Finally, change negative steep fill slope to positive steep cut slope. In some cases, our bench starts when our cut excavation height reaches 7 meters. Therefore, it's good to give our input variable to make it changeable in Civil 3D. BH. Its bench height. It's double. We will give its default value 10. Now you can give any number in Civil 3D. Change it in our condition. Finally, insert a point. It is slope to surface. It starts from point 101. Here our slope will be CS, that is our final cut slope. Its target is EG. Draw a link. As per our condition, if our excavation height is 1.4, our cut slope must be medium. We find the problem. Yes, we didn't change AP3 to AP6. It's corrected now. Let's check for others by changing our excavation depth. Yes, it works, but when we give value greater than 10, it doesn't work because it is our false condition and it will be bench. Before we go through the steps how to make benches, let's first insert bench inputs. The first one is bare H, it is our berm height. It is double. The second one is BHD, it is our bench horizontal distance. You can give any name like berm width. It is double. The third one is BHS, it is our bench horizontal slope. Again, you can give any name, it is double. The fourth one is BS, it is our bench slope. Again, you can give any name, it is double. Now we will give their default value. Usually we will give 3 meters for berm height and bench horizontal distance. Our bench horizontal slope must be slope, not double, and usually we will give 10:1 for bench horizontal slope. And again, our bench slope must be slope, not double, and we will give 1:1 for bench slope. You can give any number as per your condition. Let's come to our chart and insert a point. It is my daylight insertion point. It is slope delta y. It starts from point 101. For similarity purpose, its slope will be positive steep cut slope. Its delta y value is our berm height. Insert another point. It is slope delta x. It starts from point 103. Its slope will be negative bench horizontal slope. Its delta x value is our bench horizontal distance. Insert an auxiliary point, slope to surface. It starts from point 104. Its slope is positive bench slope. Its surface target is EG. Now we will decide. Insert a decision. Its condition will be AP9 dot y minus P10 for dot y less than our bench height. If it is true, simply insert a point. Its type is slope to surface. It starts from point 104. Its slope is positive bench slope. Its surface target is e.g., and draw a link. If it is false, insert a point. Its type is slope to delta y. It starts from point 104. Its slope is positive bench slope. Its delta y is bench height. Again, insert another point. Its type is slope to delta x. It starts from point 106. Its slope is negative bench horizontal slope. Its delta x is bench horizontal distance. Once we did it, we can repeat it a million times, but we have to use loop geometry. Insert a loop. Our loop surface target is e.g. We need to repeat links, which are link 79 and link 78. You can repeat as much as you want. We will repeat 30 times. Finally, we will make our last bench. Insert a point. Its type is slope to surface. It starts from our loop 1 endpoint. Its slope is positive bench slope. Its surface target is e.g., and draw a link. Now we have finished all cut conditions. Let's check if our excavation height is 67 meters. Yes, it works. Again for 220 meters. By the way, you can use different loop for different bench slope at a station. Yes, it works again for 220 meters. Next, we will check if it works or not for different types of ditches. Please subscribe my new YouTube channel. As you have seen it, it works for all different ditch condition. Sorry, we have to give the display name because it is visible in Civil 3D. Next, we will see undercut or replacement, as we have known. If the existing ground soil is black cotton or expansive, usually the engineer order the contractor to undercut the existing ground and replace it with suitable material. First, we will insert our input parameters. The first one is, you feel it is undercut fill is required or not. Our default will be yes when you don't need it. Simply by making it no in Civil 3D, it will automatically disappear. The second one is UFH, it is fill height. For undercut condition, it is double. Usually its default value is to meter, but you can use any number. The third one is UFRT, it is undercut fill replacement thickness, it is double. Our default value is 0.6 meter, but you can use any number. Now let's change our condition to fill, because we will make our fill condition first. Come to our flowchart. Under fill condition, insert a flowchart and open it. We can give a name fill undercut. Now we will make a decision. Insert a decision. That is if undercut fill condition is equal to yes. It is case sensitive. Please write correctly or copy paste from input parameter. If it is yes, we will again insert another decision. The condition for this decision is if our fill height is less than our undercut fill height. Please write correctly or see it on screen. P12 dot y minus P13 dot y less than or equal to UFH. I think you know it. If this condition is true, we will undercut full width. Insert a flowchart. We can give a name for it: full width undercut or any other name, and open it. First, we will draw our existing ground for full width. To make it, simply insert a surface link. Our surface target is e.g. our start x is our center line, that is P6.x. Our end x will be our catch point, that is P13.x. Depth will be 0 because we need original ground. As you have seen it, it is drawn on e.g. Now we will make our undercut. Insert a point. Its type is delta x delta y. It starts from point 109. Its delta y value will be negative undercut fill replacement thickness. Insert another point. Its type is delta x delta y. It starts from point 110. Its delta y value will be negative undercut fill replacement thickness. Now we will make links between points. Insert a link. Its start point is point 111. Its end point is point 112. Again, insert another link. Its start point is point 109. Its end point is point 111. And insert a shape. Now we have to remember one thing here. This shape is our undercut excavation shape, and it is a regular shape because its top link follow our existing ground. Therefore, we have to draw a regular rectangular shape for our replacement. By the way, you can give a code name here, but as we have discussed in previous video, we will give all codes after finishing this interesting subassembly. Insert a link for replacement. Its start point is point 109. Its end point is point 110. Now insert our replacement shape. Since we already defined this shape, it is impossible to define it by picking a point. Therefore, we will give the link by adding link. Our links are the last for links excluding the first one. Again, you can give the code name. We have finished the first condition. Now we will see the next condition, that is if our fill height is greater than our undercut fill height. Come to our flowchart. Insert a flowchart for false condition. I will give the name Balatoli Undercut because I like football, but you can give any name. As we know, during this condition, our undercut part is not full width, but only the toe parts. All the steps are similar with the above except the position. So please see the video, and please subscribe my channel. We have finished our fill undercut and replacement condition, and you can check it. I think it is enough for today. In next video we will see undercut or replacement in cut condition, how to give point, link, and shape codes, and we will import this subassembly to our Civil 3D. By the way, we can also make fill and cut retaining wall here in this powerful subassembly. We will see it. Thank you for listening. Please like, comment, share, and subscribe. Thank you again.